Hello students, welcome to this video tutorial titled An Introduction to Algebra Tiles. When using algebra tiles, there are 6 kinds of tiles you will be working with. The positive and negative integer tiles, which we have seen before in the integers unit. The positive and negative x tiles, we have a long rectangle with a positive sign, and then we have a long rectangle with a negative sign. And then the positive and negative x squared tiles. Now these are very large squares with a positive x squared or a negative x squared in the middle of them. Okay? All right, let's begin our examples. So example 1, we can do from our study of integers. We have a positive 4. So if we look at the algebra tile bin here, we have the 6 kinds of tiles. We have positive 1s, negative 1s, positive x's, negative x's, positive x squares, and negative x squareds. So to represent positive 4, this is an expression, we bring over 4 positive tiles. And you should probably get in the habit of arranging them in a fairly neat cluster. They can go horizontal, they can go vertical, or you can have a 2 by 2 grid, as long as they're all packed together and they're easy to count. So this is very easy to identify that this is positive 4. Let's go to example 2. We're asked to represent the algebraic expression negative 2. So we're going to bring over 2 negative tiles, and we're going to cluster them together, put them very close to each other. So this tile diagram represents this algebraic expression. Let's go to example 3, 2x. Now if there's no sign in front of it, then assume it's positive. So this is positive 2x. So we need to grab tiles from this part of the bin, the positive x's. So we'll grab 1, and then we'll grab 2. Okay, again, you can stack them vertically. You can have them side by side, horizontally, as long as they're very easy to identify. Let's go to example 4, negative 3x. So the negative x tiles are these tiles, and we need 3 of them. So we're going to bring over 1, 2, and 3. Okay, and we have them all this time kind of lined up horizontally. Okay, so those were the easy ones, just to kind of get us going here. All right, let's go to the next slide. Okay. All right, so we're going to combine different types of tiles now. So let's look at this. So let's look for the x's first. So we have a negative x. Okay, so that's this tile over here. So we'll have a negative x. And then what's the other part, or the next term in this algebraic expression? Well, we have a negative 3. So even though this is subtraction, this is a subtraction sign, I want you to include the subtraction sign with the integer, so we have negative 3 here. Okay? So what I want to do is, I want to cluster the integers, the negative 3 tiles together, and I want to have this little separation between the x tiles and the integer tiles. We always want to put the x tiles first. In this case, it came first in the expression, didn't it? All right, let's go to example 6. So see if you can kind of get ahead of me here. So we have 2 terms. So let's look for any x terms first. So we have 3x. So how would we represent 3x with these tiles? So I'm going to bring over 3 positive x tiles, 3 positive x rectangles, and this time I'm going to stack them vertically. So that takes care of all of my x's. Now, are there any integers left? Well, there's a positive 2 here. So how would you represent positive 2 with these tiles? So this is the completed tile diagram for this expression, 3x plus 2. We want to have the x's in front, and then we want to have the integers behind. Okay, let's go to example 7. Let's look for any x values or x terms. So we have negative 4x. So how would you represent that? Okay, so I've got my negative 4x tiles, my negative 4x rectangles, and I've clustered them all together. You could have lined them up horizontally, or you could have stacked them vertically. I put them in a 2 by 2 grid. And then what else is part of this algebraic expression? I have an integer, positive 4, positive 4. So let's bring over 4 positive tiles. And there is my tile solution for negative 4x plus 4. All right, let's have a look at example 8. Very simple one here. X. Now again, if there is no number in front of a letter, then assume it's 1. So this is 1x, and it's a positive. So let's bring over a positive x tile. And then we look at what integers remain. So we have a positive 5. Okay, so there is my algebraic tile diagram for the algebraic expression x plus 5. Okay, let's move on to the next slide. All right, so for example 9, we've introduced the last type of tile that we haven't used yet. So what we want to do is we want to look for any x squareds. So I see one x squared term here. And again, there's no sign in front of it, which means it's positive, and there's no number in front of it, which means it's 1. So let's bring over one of these big tiles. This is x squared. Now let's look back at our algebraic expression. Let's look for any x's. So in this case, we have positive 2x. So how would we represent that part of the diagram? And then we go back to our question or our algebraic expression and we look for any integers. So we have a negative 1. So that's fairly simple. Negative 1. Okay? So we always want to put the x squareds first, then the x's, then the integers. X squareds first, then the x's, then the integers. We always want to kind of line them up kind of left to right here. Okay? All right, so why don't you see if you can do number 10. Now number 10, I've kind of jumbled the order a bit. So always look for your x squared. So I'm going to highlight this, and this is what I'd like you to start with, and I'm going to give you a little bit of a head start. So we're going to start with negative 2x squared. So to represent negative 2x squared, we have to use one of these tiles, the negative x squared tiles, and we need 2 of them. So let me bring over 2. Now I could have put them horizontally, but I'm going to stack them vertically because I always want to go left to right when it comes to my x squareds, my x's, and then my integers. Okay, let's look back at our original question, our algebraic expression. Let's look for any x's. So in this case, I've highlighted negative 3x. So how would we go about building that term? Okay. Now let's go back to our question, our algebraic expression. And finally, lastly, we look for any integers. We have a 3 and we have a plus sign in front of it. That means positive 3. So let's bring over 3 positive tiles. Okay, so that's this diagram completed. We have the x squareds first, then the x's, then the integers. Even if they didn't appear that way in the question, that's how you have to organize them in your answer. Okay, let's go to number 6. All right, slide 6. example 11. So again, I'm going to look for any x squareds. So it looks like I have three x squareds, three positive x squareds. So I'm going to line them up here. Okay. Go back to my algebraic expression and I'm going to look for any x values or x terms. So I have positive 2x. Okay. And then I'll look for any integers. So I have a negative 4. Okay. Again, we have our x squareds first, our x's, and then our integers, always from left to right. Okay, let's go on to example 12. Let's look for any x squareds. Now, something different about this question in that there are two terms that have x squareds. So let's see how this is going to work. So let's take care of this one first. Negative x squared. So that means a negative 1x squared. I'm going to bring it over. And then we have negative 2x squared. So we're just going to combine them with what's already here. Negative 2x squared. So let's bring over two more here. So we've got 1 and 2. Now I can cluster them this way because it's very easy to see that there are three of them here. We have 1 here and then 2 more here. All right, let's look for any x values. So we have an x value here, and we have an x value at the very end. So we're going to get to that. Let me take care of the 4 x's first. So these are positive x's. So let me bring over 4 of them. Okay. Now remember, there's one more positive 1x at the end. So we have to add one more positive x rectangle or tile. Okay. Now let's scan our algebraic expression. Are there any integers? And it looks like we have one integer here, which is negative 2. So let's bring over two negative tiles. Okay. So you can group these any way you want, as long as you have the x squareds first, then the x's, and then the integers. So at this point, we're going to stop the tutorial, and what I'd like you to do is I'd like you to work on this activity here called representing algebraic expressions and equations with algebra tiles. So you're just going to use this note as a model, and then you're going to create these tile diagrams. I would like you to complete until question 16. Question 16 on slide 9. I want you to stop at question 16. All right, thanks for watching. Bye.